Lesson: Selecting appropriate machine learning frameworks. Selecting appropriate machine learning frameworks is a critical step in the model development and deployment process, especially for professionals aiming to excel in the field of artificial intelligence. With an array of frameworks available, each offering distinct functionalities and optimizations, choosing the right one involves a strategic assessment of the project's requirements, the team's expertise, and the intended deployment environment. The right framework not only enhances productivity, but also ensures the scalability and robustness of AI models. This lesson delves into the actionable insights and practical tools necessary for making informed decisions about machine learning frameworks. The primary consideration when selecting a machine learning framework is the nature of the project at hand. Different frameworks are tailored to handle specific types of tasks. For instance, TensorFlow, developed by Google Brain, is renowned for its flexibility and scalability, making it suitable for both research and production environments. TensorFlow's extensive ecosystem, which includes TensorBoard for visualization and TensorFlow Lite for mobile and embedded devices, makes it a versatile choice for projects that demand a wide range of functionalities. In contrast, PyTorch, developed by Facebook's AI Research Lab, is often favored for research due to its dynamic computational graph, which allows for more intuitive model building and debugging. An actionable insight when deciding between these two popular frameworks is to consider the team's coding preferences and the specific requirements of the model development process. PyTorch's Pythonic nature appeals to developers looking for a more straightforward and flexible coding experience. This is particularly beneficial in scenarios where rapid prototyping and iterative testing are paramount. Statistics show that PyTorch's adoption in the research community has grown substantially, with over 50% of machine learning papers referencing it as of 2020. On the other hand, TensorFlow's comprehensive deployment capabilities make it a strong candidate for projects that need to transition seamlessly from research to production. The choice of a machine learning framework is also influenced by the deployment environment. For instance, if the goal is to deploy models on edge devices, TensorFlow Lite or Apple's Core ML might be more appropriate due to their optimizations for mobile and embedded systems. These frameworks are designed to reduce the computational and memory footprint of models, which is crucial for devices with limited resources. Furthermore, the integration capabilities of these frameworks with cloud services such as Google Cloud AI and AWS SageMaker can streamline the deployment process, allowing for efficient scaling and management of AI applications. Practical tools like AutoML frameworks can also play a significant role in the selection process. AutoML tools automate the model selection and hyperparameter tuning processes, enabling professionals to focus on higher-level tasks and strategic decision-making. Google's AutoML and H2O.ai are notable examples, offering features that automatically optimize models for specific tasks, such as image classification or natural language processing. These tools are particularly advantageous when dealing with large datasets or complex models, as they can significantly reduce the time and expertise required to achieve optimal performance. Real-world challenges often demand a balance between accuracy and interpretability, especially in industries where regulatory compliance and ethical considerations are paramount. Frameworks like scikit-learn are well-suited for projects where interpretability is a priority, providing a suite of simple and efficient tools for data mining and analysis within a unified interface. Scikit-learn's emphasis on simplicity and efficiency makes it an excellent choice for educational purposes and projects that require quick, interpretable results without the complexity of deep learning models. Another critical factor is the framework's community and ecosystem. A vibrant community can provide invaluable support, resources, and continuous updates, which are crucial for staying ahead in a rapidly evolving field. For example, the TensorFlow and PyTorch communities are known for their extensive documentation, tutorials, and forums, which can be instrumental in overcoming technical challenges and accelerating the learning curve for newcomers. Moreover, when addressing real-world challenges, it is essential to consider the integration capabilities of the chosen framework with existing systems and technologies. The ability to seamlessly integrate with popular data processing tools such as Apache Spark or Hadoop can enhance the efficiency of the data pipeline, thereby improving the overall performance of the AI system. TensorFlow on Spark, for instance, enables distributed training of TensorFlow models on Apache Spark clusters, combining the strengths of both frameworks to handle large-scale data efficiently. In summary, selecting the appropriate machine learning framework is a multifaceted decision that requires careful consideration of the project's specific needs, the team's expertise, and the deployment environment. By leveraging the strengths of various frameworks and practical tools, professionals can address real-world challenges effectively and enhance their proficiency in AI model development and deployment. The integration of actionable insights and strategic decision-making in this process not only ensures the success of AI projects, but also contributes to the advancement of the field as a whole.